Synth Design Podcast, Synthux Academy, Roy here. I'm super excited to share with you today an interview I had with Nick Donaldson from Infrasonic Audio. Nick is the brain behind Audrey 2. And if you guys are not sure where the name Audrey 2 is coming from, the remarkable Sophie Bollman drew this illustration for us. I don't know if you guys know that film from the 80s, Little Shop of Horrors. Comment below if you're an 80s child and if you like horror, because this is all about horror. And I thought this is a really good opportunity to get back to the podcast because understanding how this thing actually works is way beyond my capacity. And I did make some small mistakes in the way that I explained it. So I thought it would be really good to have the engineer behind this to explain to us what is Karplus strong synthesis and what is the difference between Karplus strong synthesis and this. Because Karplus strong can sound awesome, but also very digital, and this does not sound digital at all. So how does it sound so organic? We also talked about this is basically a project that started as a grad seminar. So Nick is talking about the initial steps towards this and his fascination with feedback, and then going towards the recent projects he has been working on, which is Worp Core, the module, and Disentangler, which is a really new module that he's super excited about. He talks about his transition from being mainly an iOS developer towards an audio programmer, DSP specialist, and how the Synthux community was actually part of this, which is really warming my heart. It's really exceptional to talk to people like this and to learn from one another. And if you're part of the community, thank you so much for being part of the community. And if not, then click the link below and join our community. We're a non-profit organization, and everything that we do is to bring these instruments and to help designers, musicians, illustrators, artists to realize their ideas and release instruments to the world. Without further ado, Synthux Academy, Synth Design Podcast, and this is the interview with Nick Donaldson from Infrasonic Audio. Enjoy. Nick, welcome.
Hello. Thank you.
Thanks for joining the podcast, the interview. It's been a while since I did these, and I thought because we're now releasing Audrey, it's actually a perfect opportunity to maybe get back to this.
Great.
Yeah, so it would be great to maybe start by maybe giving a little introduction and explaining a bit about how Audrey came about.
Sure. So the sort of core concept behind the synthesis engine is the idea of a very crude physical model of string feedback. So it was actually originally part of a grad school seminar that I was taking that was focused on physical modeling. And I, for my final project, wanted to try to emulate the sound of an electric guitar feeding back. And there are a number of ways that can happen, but one way is the speaker, so going through the amplifier, the sound coming through the amplifier continuing to resonate the strings. So the actual sound waves in the air resonating the strings of the guitar, which then increases in a feedback loop and creates that classic kind of feedback howl. I think Jimi Hendrix was one of the first pioneers of that sound. Maybe not the first pioneer, but he was, known for that feedback sound in a time when not a lot of other popular artists were doing it. So that was the core idea, and it's conceptually, like from a physical modeling standpoint, it's a really crude and simple way of doing it. It's actually similar to a Karplus strong kind of string resonator, so just a tuned delay line where the length of the delay line is equal to the fundamental frequency of the string or the sound. And then rather than sort of seeding that with like a burst of noise, which you would do in Karplus strong or a pluck kind of broadband sound to get into the delay line and resonate with a high degree of feedback and eventually decay out. In this case, there's no sort of input to that delay line. It's just very low level noise, just sort of like ambient noise in the system that is then put through distortion and an additional delay to sort of simulate the time it would take for the sound wave to propagate from the speaker to the string. Mm-hmm. So then that builds that feedback up in the delay line continuously, and the distortion sort of shapes the harmonics. The outer delay time determines which parts of the harmonic spectrum actually end up becoming dominant in the resulting feedback. So that's kind of the seed of the idea. It was this grad school project I did to try to simulate electric guitar string feedback. And in that project, I was doing it in a way that was like, okay, it doesn't really sound a whole lot like an electric guitar, but the feedback actually kind of sounds like guitar feedback. That was the most interesting part of it. The rest of it was like, the actual simulation of a guitar string is like, whatever, that doesn't really matter. This is the cool part. And so I thought that concept, that sound, that feedback in a really simple closed loop physical modeling delay system was fascinating. And I've iterated it a lot since then. And what eventually became the synthesis engine for Audrey is sort of the most recent version of that, I guess.
Cool. So how did your teachers accept this experiment?
Yeah, they really liked it. Man, that grad school seminar was so cool. It was actually Gary Scavone was the professor. He's one of the co-authors of Synthesis Toolkit, STK, and RT Audio, RT MIDI. Really, really popular open source libraries for real-time audio and MIDI and cross-platform desktop environments, as well as sound synthesis in C++, coming from sort of an academic space. And I think the other author is Perry Cook. I think he was from Karma at Stanford, but I could be wrong about that. But anyway, Gary Scavone, really knowledgeable guy about physical modeling, and such a chill seminar, like really nice guy. He actually reviewed my master's thesis as well. He was, I forget what you call it, the reviewer of that. And yeah, I remember the demos at the end of the seminar. It was like the snowiest day ever. It was in Montreal at McGill. It was the snowiest day of the year. It was like 2 meters of snow on the ground. It was insane. And of course, in Montreal, they never really cancel anything. That's just normal. Yeah. So I had to trudge down and we had to do all our demos. And he had brought a bunch of beer. He was like, yeah, grab a beer if you want. We're going to do our demos. It was great. And so, yeah, that demo went well. Some of the other ones were awesome. It was just a super fun environment.
Cool. Actually, that's really interesting. I had no idea that it started as a grad project. So yeah, that sounds like a really fun teacher to have, regardless of the knowledge. Being a teacher, I know how important it is to build these relationships with students, and he sounds like he knew how to do that. Yeah, that's really cool. So you touched a little bit about the engine and how it actually works. What really amazes me is how natural this sounds. Like how, I mean, this is a computer. These are digital bits, but it actually sounds like I would even say sometimes better than like conventional feedback, because conventional feedback is really, really hard to control. Can you maybe take us through the signal flow and how that thing actually, like, what makes it sound so analog, or not even analog, but because I guess it's not really an analog emulation, it's more like a physical emulation.
Yeah, I think there's probably a lot of ways to attribute that. The core idea, which I explained a little bit earlier, is this idea of like a resonant delay line. So forms the basis of Karplus strong synthesis, and sort of in its simplest, most naive form, it actually sounds really digital. So that's interesting that this evolved into something that you described as not sounding. I would agree. It doesn't really sound like, oh yeah, that's definitely a computer making those sounds. But the core idea of a resonant feedback delay line like if you've ever played with a delay on like a really short time and turn the feedback way up, you get this sort of like brrr, like it's pitched. It has a pitch to it, and that pitch is the length of the delay line. Is one period of the fundamental of the sound you're hearing. But if you just do that, it sounds really digital. It sounds like artifacty almost. Like it's hard to describe it, but it just doesn't sound like something natural or analog per se. But I think the idea of feedback is not that like you're putting a lot of energy into that system initially. It doesn't have any energy in it. There's really almost nothing going through that short delay line feedback loop. The outer feedback loop is what is causing that system to continue to gather energy. And I think the keys there are there's three things in that outer loop. So you've got the inner loop with the short delay line, and the tuning of that determines sort of like the string pitch, if you will, sort of the fundamental frequency of the whole resonating delay line system. But then there's an outer loop. So we've got this tight loop where the delay line is just feeding back on itself with some high amount of feedback. It won't, in and of itself, that feedback coefficient is less than 1. So it's not going to just like, if you took out the outer loop and you gave it like a little burst of sound, it would decay away. It would sound like a Karplus string kind of string pluck. But instead, with that outer loop, I think these elements are the keys. The outer loop takes the output of the delay line at the end, just one tap of it, puts it through soft clip distortion. So just a standard like TANH distortion curve or similar to which adds harmonics eventually as the engine builds up. That's going to sort of clip off those peaks of the resulting sound wave in a soft way that generates odd harmonics. And then it goes through, I'm not going to talk about the reverb yet, just the core elements that give it the sound. The next thing is another delay, much, much longer than that short delay. So this is the idea of like the distance between the speaker cabinet and the guitar. Much, much longer in relative terms. Obviously, that's still pretty short. The sound wave can travel pretty quickly through that distance. But compared to, the very short delay line, which is, one period or one wavelength of your target pitch, this one is a bit longer. And then it's also filtered at that point. So there's a high pass, low pass filter that's controllable. And what all of that does is from nothing. There's also a gain coefficient. So how attenuated is the sound that's feeding back in the outer loop. And what that does, when you turn that gain coefficient high enough, we start to get energy building up in the inner loop and then feeding back through the outer loop. And the outer loop, with the distortion and the filters, that's sort of what's shaping which harmonics are sort of present in that outer loop and able to feed back into the short loop. And the relationship between those harmonics and the natural harmonic spectrum of that short resonant feedback loop, which pretty much has all the harmonics in decreasing amplitudes, also has a minor low pass filter on that inner loop. That's what's determining sort of the overall shape of the feedback and how it evolves. And Audrey, there's also a fixed, very slow random LFO on each channel. It's a stereo, so there's two of these things happening. And there's a slow fixed LFO on each channel controlling the delay time and the outer loop. So that is sort of modulating what you've chosen with the body control, which is the length of the delay in the outer loop. Shortly modulating that delay time is going to shift those harmonics, and as they build up, they're going to change a little bit. So it's not just like that static sound. I think that's key to it sounding a little more alive and natural. But really all of that, the filtering, the distortion, the delay time, all factors into kind of what is building up in the system in terms of sonic energy. And the filters especially have a really important effect. I think you've done some demos with Audrey, and anybody who's used it will notice that if you have the low pass filter all the way open, so it's not doing anything to the sound, and then you turn the high pass filter up, so you're starting to sort of filter out the lower part of the spectrum in the outer feedback loop, it gets really harsh. And that's where I think it still sounds pretty cool and pretty, like, to use your word, natural, but that's where I think you start hearing a lot of that, what could also be described as like digital harshness. It's like those higher harmonics just get really screamy and wild. So the filtering has a massive effect on it. So really it's all those components coming together, and that slow modulation is what gives you the difference in the stereo, as well as keeps that spectrum sort of shifting and moving a little bit. Because if it were to become static, you know, and you're not changing any controls, you're just going to get a constant howl of feedback tone that's not changing at all. So that is one component to help it sort of keep moving a little bit, even if you're not turning the controls.
Before you continue to the reverb and the delay, can you maybe talk a little bit about the body knob? Because I just made a couple of videos, and one of the videos I'm trying to explain what I'm doing. And at first I was like, yeah, I'm playing with the harmonics. I was like, but this is not like I'm going through the filter. I mean, we designed it as like it's in between with the filters, but it's like a large knob. And I remember that you were explaining that this is like a really prominent thing to play with. And now you're elaborating on the fact that it's actually the distance. So this is actually the outer delay line, as I understand. Right. So is this like literally the distance that
it's in the sort of guitar amp string feedback analogy? It's kind of the distance. It's the delay time between the sound of, you know, the sound wave exiting the amplifier and reaching the strings. So if you bring your guitar really close up, that's in a real system, that's obviously going to also affect the amplitude, because you're closer to the speaker, right. You're getting more amplitude into the strings. Farther away, you're getting less. In this system, that's not an inherent relationship between the two things. You can control them separately. So the feedback knob, or I think is a drive on the actual panel, drive or feedback.
It doesn't have any word next to it.
Oh, right.
Yeah, it's just like
yeah. So that's actually the attenuation of that outer feedback loop. So the more you turn, or the gain, it actually turns into gain at some point. So the more you turn that up, the either attenuation or multiplication of that signal. So that's two concepts from the actual physical guitar analogy are now separate. You've got the amplitude, which is that knob, and then you've got the distance or the delay time, which is the body knob. So you've taken this signal, which is some oscillating waveform with a bunch of harmonics. We've distorted it, we've delayed it, and now we're putting it back into the delay line. So the delay line has, you know, this waveform developing in it. This wave fits within one period of that delay. So one length of the delay, we've got some wave that's starting to build up in there. We've taken that wave output, put it through the outer system, and we've delayed it. So the amount of time we've delayed it determines the phase cancellation, destructive or constructive interference we get back into the delay line. So if it's exactly that, you know, exact multiple of the length of the inner delay, if our outer delay is an exact multiple, then in theory we should get constructive interference. We've got that same wave coming around in the same phase. So all of those harmonics are going to stack on top of each other and start building. But if we change that slightly, and now it's coming in at a slightly different phase, post distortion, you know, it's got other things that have happened to it. So the actual wave is different harmonically, and it's different in phase. We're going to get a different constructive and destructive interference when it comes back in. And that's going to influence which other harmonics actually get accentuated and build up now because of that interference. So as we're changing that outer delay time, we're sort of changing the interference pattern that leads to the emergence of new harmonics in the sound. And of course, again, all that is also subject to the distortion and the filters. So if you're filtering out, you know, certain bands of energy, low pass or high pass, then those harmonics are obviously not going to build up because they don't exist anymore. You've gotten rid of them.
Yeah. And then does all this feed into the reverb, or does
reverb's actually in the outer delay loop? That's the cool thing, and I remember talking about this with you because
Yeah.
you were like, yeah, what if we put a reverb in? And I was like, that's a cool idea. So the reverb is actually in the outer delay loop. And if you, again, we've deviated so far from the idea of like a guitar,
Yeah.
but it's still interesting to think about. If you had a reverb pedal in your signal chain before it went into the amp, it's kind of the same idea, right? Like you've got this outer delay from the speaker back into the strings, which is then going through a reverb.
Mm.
And so by putting the reverb in that outer delay loop, not only are we just taking that signal and feeding it back in on itself, we are putting it through a reverb, which in itself is a giant network of delays and all passes. I think in this case, it's just the stock Daisy Big Verb, which is a Sean Costello design that's no all pass filters in that one. I think it's just a bunch of modulated delay lines. So more delay lines. Yeah, it's all delay lines all the way down. That diffuse and prolong that sound through their own sort of inner network. You could think of it like a bunch of series of delay loops. We've got our original string short resonant delay. We've got our outer big loop, which itself goes through this big network of delay lines that are looping around themselves and then taken back into the original resonant delay lines. So yeah, the reverb just kind of does really cool stuff. I mean, like that's a part that a lot of this I had originally, studied and done the math and modeled for this grad program, but that is just like, to do the math for that, forget it. Like it sounds really cool. It's doing cool stuff, but the actual precise math for what effect is this having on the system, it's beyond me. It just sounds great.
It sounds amazing. I had a chance to play quite a bit with it in the last 2 weeks. And I discovered a lot of things that are really like mesmerizing when you you can just actually leave the feedback knob, the main one, not really feedbacking, but because the room is really big, it's actually oscillating, but not enough for it to like go all the way to like massive distortion. So it just like plays on its own. And like I left it and I had to like go to the kids to like do something, and then I was like, this is crazy. It's like playing in the back all the time. And they're like these sweet spots that if you discover them, this is like a whole world of like another dimension of exploration of sound that to be honest, I couldn't really think about any other device. Maybe my knowledge is limited, but like, is there any instrument that's designed this way for like feedback? Because I know a lot of people are like doing stuff with feedback, like working with analog mixers and messing around, or like I did a bunch of things here also, even with a 2HP reverb that has like a stereo in and stereo out. You could easily make some interesting feedback there, but it's very, very limited, and you do need to patch a lot to get to something that would be interesting to perform with. Mm-hmm. Are there any instruments that you know of that are in the space?
Not off the top of my head. It's not, it's not a space I know a ton about. My own musical explorations and interests are typically not in the ambient side. I think that stuff's really cool, but it's just not something that I do much of or really explore much of. So I'm not aware of it. I mean, there are certainly other sort of drone engine type instruments, but specifically based around feedback with no other sound source. Not that I'm aware of. The only one that comes to mind is, and I'm a little embarrassed I don't remember the name of it. It's an electroacoustic instrument based around like a spring reverb with a filter bank. So it's a spring reverb that feeds back on itself through a filter bank. And it's like some boutique handmade electroacoustic instrument that has like a 5-year waiting list. And I apologize to the maker of that. I don't remember the name of it. But it's pretty cool. And it's just a fed back spring reverb with a filter bank to sort of control how the feedback is influencing the resonant, the resonance of that spring reverb. And it's beautiful. It creates these like haunting bandpass tones. That's the only one I can think of, and that is an electroacoustic instrument.
Yeah.
There's actually a physical spring involved.
Yeah.
Whereas this is just purely digital.
Yeah, I feel like the fact that it's purely digital allows for this creative freedom because you can really like design how these things are intertwined, connected together. You're really able to do things that are extremely hard, if even possible, in the physical space. Like you would need a lot of experimentation, exploration, while this is just like a self-contained unit that is yeah, like just really surprising. You can get to like really wild, harsh sounds that then you would put into a voltage controlled amplifier, for instance, and create these really, really interesting rhythms. And at the same time, you could like turn this VCA all the way up and like just like drone with lots of harmonics, many of them really surprising. Yeah, and like at least it felt like if I'm not really using the frequency knob but only the body, I'm still playing in the same not really in the same scale, but like like the notes are actually corresponding like to each other in on like harmonically.
Yeah. Everything you hear, if you're not touching the frequency knob, everything you hear will be harmonically related to whatever the fundamental
Yeah.
frequency is set by that knob. That's the length of that inner resonant delay line. So yeah, as the harmonics build and develop, they're all harmonically related to that frequency.
Yeah. Cool. So maybe let's talk a little bit about 2022. This was like this project basically came like I discovered about it back then, and we started working on the design, like making it into a product. I know that you have it, maybe the first version of the designer. Maybe you can show that.
Yeah. So this was the sort of first version that you sent me this board, and I built with the kit. I don't even remember if it was a kit. I think I had some of these parts on hand, or I bought them myself. But the PCB came, and so yeah, it was a chance to actually put a interface to it in a really easy way, and that was really fun. That sort of unlocked it. I had previously done a bunch of versions of it in software, so I'd controlled it with MIDI controllers and things like that. And I had done a version on the Seed, but I think I was also MIDI controlling it at that point. And then, yeah, I got the simple designer board, and that was just a super easy way to wire up some controls and have something somewhat permanent to play with the design and play with ideas.
Yeah, I feel super fortunate that I was that I could actually be part of this, and like be part of like seeing this process was really inspiring. When you joined the Discord community was because of the hackathon that we did, I think, right? Like this was the first moment.
Yep.
And since then, like you were like I would not exaggerate saying like one of the pillars in the community. You shared a lot of knowledge about digital signal processing and help people sort of like wrap their heads around even like people that are now the ones who would support other people basically rely on knowledge that was gained from like conversations and chats with you and like code that you shared open source on GitHub. Can you maybe talk a little bit about the process of getting into instrument design? You mentioned just now that you actually designed stuff on your computer. Was this the first physical thing that you designed?
Yeah, that's a good question. This was not the first physical thing I had designed. I had done various projects throughout the years, a lot of them very much on the DIY scale. Things for, just like art projects and things like that, just for fun.
Right.
This was probably the first thing that kind of turned into a more, permanent instrument, let's say. Obviously now with the designer instrument being released. But yeah, I think my background, I actually studied electrical engineering as an undergrad, but I got really into DSP. So the actual analog and circuit design parts fell a little bit by the wayside. I got really into programming and doing a lot of computer music stuff for a number of years.
Mm.
I actually wasn't, throughout my career, I've been a software engineer for over a decade, but throughout my career, very little of it has been explicitly focused on music and like sound stuff in a professional capacity. So it's always been more of like, that was my passion. That's what I studied, and it got me in the door of software in a completely different industry. But yeah, maintaining that throughout the years as an interest, and then eventually turning it now into a full-time career has been really rewarding. And yeah, the community, I think, is a big part of that. Like, being able to design this instrument was really fun, and it was kind of like, hey, I can probably do a lot more than this. No offense, like, it was great. It was a great foot in the door. It was like, yeah, this is actually, I can do a lot more than this. So that was cool. And then learning a lot from the community as well. Like, I felt like I could share programming stuff because that's what I know really well in DSP. And then learning a lot and refreshing my memory about something, but also learning a lot of new things from other members of the community when it comes to other topics in synth design was really helpful, and kind of kickstarted that part of the journey as well.
Yeah. So you talked about the fact that you actually worked in the industry as basically a professional developer. What languages were you working with? Is this like iOS developer or like a web developer? What were you doing?
Yeah, iOS for a lot of it. I kind of got into iOS through a very short-lived and ill-fated startup in Boston that was doing a music remixing app. Cool concept, and I got hired to write the effects for that because what I knew how to do. I was writing digital audio effects in C++ and C at the time, but I learned Objective-C, and they tie together, Objective-C++. There's interoperability. So I learned Objective-C at the time. It was like 2010, 2011, or right around the first iPad had come out. And that's what they were doing, like a music remixing app for the first iPad. And so I was writing the effects for that, got into iOS development that way, learned how to actually work with Objective-C at the time and the iOS SDK. And that startup did not last long. And I needed another job. So I was like, well, hey, iOS is kind of blowing up right now. Maybe I can get a job doing that. And that's kind of what I did. I got a job as a developer at a consulting firm doing iOS apps for other companies. So they would get hired to build apps for other companies, basically. And that I highly recommend as a way to learn anything is to work in a consultancy, because you're working on a different project every 3 to 6 months, usually.
Yeah.
So you just get exposed to a ton of stuff really quickly, and you get to learn a lot. You have to learn a lot. And from there, it was, I got really good at iOS and kind of made a career out of that. And that's kind of where things went. I, learned C and C++ in college and never forgot any of that. That was always, skills that I use every day now. I'm writing pretty much everything in C++ now. So, that was kind of that part of it. And I worked at Isotope for a few years as well. They had an iOS app that they were doing for their Spire Studio product. And so I got hired to work on that at Isotope. And that was really cool to be part of an actual music company for a bit of my software career.
Cool. And then the shift towards like building instruments, can you anchor this at a certain point, or were there like a couple of moments where you felt like this is like another shift or another leap towards like becoming a professional instrument maker?
Well, I think so. I got into Eurorack around 2015-ish, and that really got me more into hardware synths. I, have always been a musician, grew up playing guitar and piano and, rock and blues type music.
Yeah. Got
it into electronic music a little later and did a lot of computer production throughout this whole time. Had done a bunch of, in the box production and stuff like that, and messed around with Pure Data and other computer music type creative environments. But transitioning to hardware was kind of when I got into Eurorack, and then started building more of a hardware setup in my studio, getting really interested in sort of the finite nature of hardware, I think is a good way to put it. Like, it is what it is, and there's something beautiful about that.
Yeah.
So, you know, with software, it's like anything, you can do anything, anytime you want. And with hardware, even with digital hardware, like, you kind of design it around a specific concept, or it's designed around a specific concept, and it is what it is. And there's something really nice about that. It does its thing, and that's what it does. And so that really kind of resonated with me as far as like, you know, not having infinite possibilities at your fingertips all the time, both as a performer and a maker designer. I think the first I got into, sort of like a stepping stone to that, was actually the Axolotl platform, which is like a little sound computer device with a visual programming language. It's kind of like Max or PD. It's kind of like their own proprietary thing, all open source. And so I was making some instruments around that with, you know, external control, and they kind of, you know, it's a little box that is what it is once you program it. Of course, you can change it, but you program it with a patch, and that's what it does. And so I had made a few instruments with that, and I was like, this is really cool. Like, you know, what's it going to take to actually, I didn't design this hardware, I'm just writing the software, but what can I learn about the hardware design part and the interface design part? Because this thing doesn't have an interface. It's just a box with a bunch of, you know, it's got some pins that you can add external hardware controls to. It's got MIDI in and out and stuff like that. So yeah, what can I do with actual hardware design, and what can I do with, you know, interface design that isn't going to be like, I'm not going to have to learn like everything all at once and feel completely overwhelmed. And actually Daisy was a great platform for that. The Simple Designer board was a hardware platform that already existed that could be semi-permanent and use Daisy. And I really liked the Daisy platform. I didn't have to think about how do I design a circuit around STM32 and handle all the PCB layout and everything like that. It just is what it is. It's already ready to go. I didn't have to worry about those parts. I could think about the parts that I either already knew how to do or felt more confident with. And yeah, that proved to be a great stepping stone to doing my own instrument design.
So actually it was back then in 2022?
I had Daisy before that. I had Daisy the year before. I think I had picked up the first one. But the Axolotl stuff was even years before that. That was like 2017, 2018. I started messing around with that. And then
yeah. No, but I mean, if you're thinking about the point where it actually became like, I'm now a professional instrument maker.
Oh, that was with Worp Core. That was my first, like, okay, I made a thing that I put out into the world. That was 2023 that was released. So about a year ago.
Right.
And that took about a year to develop. I did a VCV prototype first, but that was around that time was when it was like, okay, this is something I think I can do.
Yeah.
And here's a way I can do this that's not going to require me to kind of like know everything from the ground up. And I want to learn. That was always my goal. I want to learn all of that. I want to get good at every aspect of this. But this is a way that I can sort of do it within my own abilities and actually get something out there that I am proud of making and continue to build that skill set as I learn more.
Yeah. So like let's talk about this a little bit, because you actually, so there was this Axolotl experiments. You had some DIY builds that you made on your own. Then there was the Daisy, the Simple Designer board, and then there were like a couple of projects there I know that maybe you want to highlight, that became like basically from the community, right? Like you met a few people and then you started like working on things, and then on your own 2 modules.
That's right. Yeah. I mean, around that time I had just left my job, which was, I'd been at for 6 years, a software startup job. And I was kind of really looking for a complete change of everything. And so my goal was to release my own instruments eventually, but I knew that was going to take time. So part of the plan for like, if I'm going to do this, I need to keep making money and keep learning somehow. Kind of going back to what I said earlier about joining a consulting consulting firm, if you're a software developer or whatever, great way to learn stuff really quickly was, well, I noticed there were people in the community, people I was meeting in the synth world in general, who were great analog designers. You know, they could do PCBs, they could do circuits, they could design panels and instruments, you know, all the interface and everything, but they just hated programming, or they didn't know programming very well, usually some combination of both. It's like, well, that's the part that I'm good at, but the other parts that you are doing are the parts that I'm less experienced with, I want to get better at. So it's like, well, I can maybe do some consulting as I'm doing this and meet people who need programmers for the project. They don't like the programming, or they don't know how to do it, but they're handling everything else, and sort of form these kind of collaborate. And I hesitate to call it a collaboration, because as a consultant, it's really their project that I'm contributing a part to. I didn't design the instrument. I'm not taking credit for that. When I do these projects, and I have continued to do them, that's the majority of my business. I've done a ton of consulting work since then, and I really enjoy it. But that was kind of like, this is great. I love doing this stuff. I can learn as I'm doing, things as I'm doing this. I know a lot, but there's always things to learn in every project. So I can offer the things that I'm good at to help other synth developers get their stuff finished and get out there, while also learning myself in the process and continuing to work on my own designs in parallel. And that's been great. I'm still balancing that very much. Like, I would say, I have a few modules out now, but that's a minority of really what I do. The majority is this software and firmware and DSP development consulting that I do for, I think, a dozen at least clients at this point.
Oh, wow.
Least, over the last 2.5 years. So yeah, it's been fantastic.
Do you want to share any names or any projects that are maybe released or about to be released?
I can share a few that I have clearance to share. Obviously, with some of these things, there's NDAs involved.
Yeah, of course.
But the ones that are out in the public, Galix, or I think GLX now, synthesizer company, has been working on a synth called Balsam. I've been working with him almost this entire time. It's gone through several iterations. He's got, really great idea. I love this instrument. I can't wait for it to be released. But it's a polysynth built on the Daisy platform, with some really, really cool and unique control features and great sound engine. So that's one that's been kind of going the entire time. I've worked with other folks recently that I can name. One would be Demon Box, Eternal Research, have this awesome sort of electromagnetic box that you put sources of electromagnetic interference near. So your phone, cordless drills, like whatever is generating electromagnetic energy, and it picks that up and amplifies it and creates really cool sounds and control output.
I actually didn't know that you were part of this. I saw their ad and I was like, this is such a cool project. That's super nice to hear that.
Yeah, they're a great team, great folks. I contributed to the firmware for that. So
Beautiful.
The part that actually processes the MIDI and control output. So that's a recent one. I'm also currently working with ModBap, the modular maker, on several things. I can't talk about any of them, but I'm working with him, and that's been awesome. So that's just a few, and there are many more that I can't name. I'm really excited for a lot of their projects to come out, so that I can say, hey, yeah, I was involved in working on that in some small capacity, but mostly just because I'm excited for the work and the projects. I just want to see people using them and see it, success for the people I've worked with.
Yeah, awesome. Maybe talk a little bit about your own instruments. Maybe Worp Core can be a good starting point to talk about your own passion.
Yeah. So Worp Core that's my first module release, and that's an oscillator. It's a stereo phase distortion oscillator. And what really inspired me there is like the sound of phase distortion, not even necessarily from the originator, which is Casio, CZ or CZ synths from the 80s, kind of pioneered this digital synthesis technique as a way to compete with Yamaha's FM at the time. I just think some of the sounds you can create with this technique, which I actually discovered not through Casio, but through other software environments. It's like, oh, that's cool. What's this all about?
Mm.
I love the sound, and there were things that I found myself doing with it in certain other environments, like Bitwig Grid or other, even Pure Data. I had made some prototypes and using phase distortion. I was like, some of these sounds are amazing, and to be able to put these in a way that you can recombine them in a way that hasn't been done, to my knowledge, in hardware before, was something I felt like an idea worth sharing, and an instrument that I felt needed to exist. And I think that's the key, really, for anybody who's making stuff, is like, it's fun to make stuff no matter what it is.
Yeah.
But when you have an idea or a concept, it's like, I really like this, and I think it needs to be in the world because I don't know that it is in the world in any other way. That's when it really hits home. And I'm not trying to disparage anyone who's making, like, standard analog oscillators. Those are great projects. It's super fun to build anything. But once you have your own idea or your own concept that you feel like, hey, this is somewhat unique, this isn't, something I've seen done before, that's when it really like becomes super motivating to actually see it through as like something that you want to put out there in a, at a slightly larger scale, maybe. And that was Warp Core for me, was, coming up with some of these sounds and wanting to really get hardware under them so that I could, use it in my modular setup. And then learning everything that needed to go into that process, everything from learning KiCad. I had done circuit design years and years ago with Eagle, which kind of barely exists anymore. It's part of Fusion now, but the standalone is going away next year. So I was like, well, everybody's using KiCad, so maybe I should learn that. So learning KiCad several years ago, and then getting better at that and learning how to actually have PCBs manufactured with assembly involved. Those are all things I've learned in the last 3-4 years-ish, and have been able to actually put into making Worp Core. And that, it's like, I was talking to somebody recently about this who's been doing Eurorack for a long time, making modules very successfully for a long time. And, as I'm getting ready for another run of Worp Core, I'm like, why did I do things this way on the first run? He's like, because you didn't know any better. You hadn't learned yet. Everybody does this. Everybody goes through this process where it's like, oh, that wasn't the best way to do that, but it worked. It got the job done. It's just like inefficient or, slow or whatever it is. And you learn as you go, and you realize, man, there's a much better way for me to do this. So anyway, that's kind of where it's been for me, is like Warp Core. I was able to actually make it and get it out in the world. And I was very proud of that. And but it's by no means the most perfectly engineered module, especially on the hardware side, but it's what I knew how to do at the time. It was received quite well, and I was very proud of that. And I've since been refining, not changing any major aspects of the actual instrument design, but refining the processes so I can make them more efficiently and things like that. And there's an expander for that as well. That was kind of the second thing. And I just earlier this year, a couple months ago, in fact, launched my first analog module, which is called Disentangler. So that was to kind of push myself into like, can I design and produce an analog module that's I want to use and that, I think will be useful. And it's been received well so far. It's a mid-side and stereo width processor. So the simplest way to explain it is you take a stereo signal out, stereo signal in, stereo signal out, and you can control the width. So full width stereo, left and right are separate. You can sort of narrow that down to the center, so it sums it to mono and everything in between. But it does that using mid-side processing. So it's also got patch points for mid-side in and out. So you can take mid or side out to process separately, bring back in, and do crazy things with your stereo signal.
Really interesting. This is something I've actually never tried before. The Ableton utility module comes to mind, right?
Yeah. The utility module, I think, allows you to change stereo width in a similar way. It probably uses mid-side internally, but a lot of mixing and mastering plugins. Mid-side comes from sort of the studio hardware world, mixing, mastering, it's a common way to master stereo material or mix stereo material, where maybe you want to, apply a compressor just to the center channel. So like everything that's in the middle of your stereo spectrum, we want to apply a compressor to, or vice versa. Maybe you just want to do that on the sides or do it differently. And so that's what it enables you to do in a way that would be otherwise really, really difficult or borderline impossible with just standard left-right stereo signals.
Yeah. Maybe one last question before we wrap up. If you would think about the main things that someone needs to know if they're coming from a similar background like you, maybe they're developers, but they're also musicians and they play a bunch of instruments and they think this is really cool. I could actually make my living doing like programming the stuff that I really am inspired by. What's like what advice would you give, and what are the main complex things that someone needs to be aware of when they make that decision?
I mean, I guess my advice is similar to the advice I have for pretty much anything, which is just try stuff. You're going to learn by experimenting and failing and succeeding sometimes, but mostly by experimenting and failing. Just try stuff. Some things can be expensive if you're ordering hardware or whatever. So there are some costs involved, but ultimately, like, as long as you're learning along the way, just try things until they work, and figure out what you need along the way. I offer the same advice to people getting into Eurorack. Like, don't order a giant case worth of modules to start with. Order a few things and figure out what you need, and then go get that thing. It's the same when you're building skills and knowledge. Try stuff, figure out what you're lacking, and then go learn that next. Or figure out how you can, maybe shortcut it or bypass it temporarily. Like, if you want to build something based around a Daisy or a Pi Pico, go for it. Like, people will tell you, oh, it's more expensive, it doesn't scale as well. Yeah, that's true, but you'll be able to make something. And then eventually you will learn how to do those more scalable things. You don't have to do that up front. You can try it in a way that is going to enable you to do the thing that you don't know, and then learn that later. I'm just a big fan of that. I think there's sort of something very entrepreneurial about it. Just sort of like, what can I do that's going to allow me to achieve my goal? And then you'll eventually learn what you did wrong. If there is anything that you did wrong, you'll learn it. You'll figure it out. My other advice, I would say, in terms of like the complex things you need to know, just a little bit counterintuitive to the advice I just gave, but I think if you're going to, there's a lot you can do with the higher level tools, but there's a lot you can't do. And so the advice I have for a lot of people either getting into Daisy or just general like DSP or firmware programming is like, if you're using Arduino, if you're using some of, these out of the box libraries and frameworks, they will enable you to do things pretty quickly and easily, but the limits that you'll hit are actually much, much, much lower than the actual limits of the hardware. So if you like hit a limit, with Arduino or whatever it is, and it's like, oh yeah, I just can't squeeze any more processing out of this. Some of it could be the code that you wrote isn't optimized the right way, but a lot of it is this framework or this library that you're using is suboptimal or is limiting you in a way that is misleading. The actual limits of the hardware and what you can do once you dive a little lower is much higher often than you might think if you're using some of the higher level tools. And so I think that's important to recognize, and then sort of bit by bit start to pick away at, okay, what is this actually doing? Read the source code of your libraries. Obviously that's hard if you don't know the programming language well, but as you learn the programming language that you're working in, typically C, C++ for this type of stuff, read the source code of the libraries. You will learn what they're doing. You will start to pick apart, okay, how does this work and why is it doing it this way? And asking those questions maybe leads you to an answer of, well, why are they doing it this way? Maybe there's a different way to do this that's actually better. and lead you to discover those things. And that's, I think, honestly, a lot of the value that somebody with that level of experience can provide in a project like that is like, okay, we hit a limit in this project. Well, that's actually not, that's a pretty soft limit. That's, we can get past that limit pretty easily if you know what to do and where to look. So I think that's generally applies to a lot of people getting into this synth development as a hobby or a skill set, because more and more there are great tools that make a lot of this stuff a lot easier. But sometimes you have to move beyond those tools. You have to understand why they did it the way they did, and then learn how to do it a different way in order to really hit the goals you're seeking to hit.
Yeah, in a sense, like your first advice is like, if you can work with Arduino and this is where you are, be creative in that space and try to realize the vision that you have with whatever limits that you're working with. This is the definition of creativity, like, don't be a perfectionist. You don't need to know everything to get started. Work with Maximus P and make something based on ideas of others and just like realize this little idea. And then once you're there and you're frustrated because it's not as perfect as you wish, it's time to, dive into a bit more low-level programming and just gain more skill. But I think that the beautiful thing in this, if you're really appreciating the process, then it's kind of like, this is your life now, right? Like, you're always learning something new and you're always releasing stuff that you've learned just recently. The Simple Designer board is a perfect example of this. It's the first board that I made, and I had to like print it to like in JLC and stuff. I literally designed it I used KiCad as an Illustrator.
Mm-hmm.
I hit a lot of limitations, and then I met a lot of people, smart people that could help me and laugh at me that the way that I'm using KiCad is really weird. But that's how like if you're really passionate about it, that's what you're gonna do. It's just part of the process, and I really enjoy every minute. Also, the times that you're like super frustrated and just hope for it to just work. Nick, thank you so much. I think this conversation was really invaluable. I bet for a lot of people that are listening to this, I know that we have these kind of reactions because people don't really get the chance to dive into processes like that. You might have like a programming course, but no one really talks to you about like the high level idea of how to do something like you did with Audrey too. And it's also really interesting and really inspiring to see how you actually, like, where you started and where you are now, and the different instruments that came out of your love for like sound and instrument design with programming. So thank you so much for all the hard work and for joining Discord and helping everyone there. I really appreciate it. Thank you.
Yeah, likewise. Thank you for managing the community and providing a place where I could learn a lot and also contribute back. It's been huge to my success so far, and thank you for having me.
Cheers.